Everybody. In this video, we're going to talk about how to add and subtract mixed numbers. So let's start talking about adding mixed numbers when you have common denominators, because that's definitely the easier situation. So if I have 3 and 5/7 and I want to add 2 and 4/7, basically, just like with all addition, we're combining these together. And so I could take these two sevenths here and fill in this space here to make one whole. And so when I add 5/7 plus 4/7, you could think of it as having 9/7, or you can think about it as having 1 and 2/7, because you make one whole and then you have 2/7 beyond that. So because we're adding mixed numbers, I'm going to use the mixed number way of thinking about it. And to write down my steps, I'm going to write it as 3 and 5/7 plus 2 and 4/7. And when I add these together, I'm going to say, okay, 5/7 plus 4/7 equals 1 and 2/7. Because I made one whole, and then I also have these 2/7 right here. Then I can add my whole numbers together and I can say, okay, well, I have this one whole that I got by combining my fractions together. Then I have these three wholes that the problem gave me, plus these two wholes. And that means that I have a total of 6 wholes. And so the answer to this problem is 6 and 2/7. And that's how you can add mixed numbers. And notice that this is very similar to the idea of carrying or regrouping when you're adding whole numbers together. Because if you were to add your ones column, and let's say you had like 9 plus 8, when you add 9 ones plus 8 ones, you get 17 ones, but you only write a 7 in the ones column, and you carry the 10 to the tens column, and you put a 1 in the tens column. So this is a similar type of idea, except instead of grouping them together in groups of 10, like our place value system does, in this case, we're grouping them together in groups of 7 because the fractions are split up into sevens. So it takes 7/7 to make a whole. So this is how you can add mixed numbers, and you can use a similar strategy when you're subtracting mixed numbers. So if I have 5 and 1/3 and I want to subtract 3 and 2/3, then I need to take away 2/3. But I can't do that if I only have 1/3 available. So what I can do instead is I can take one of my wholes and cut it up into thirds, because then I can take away the 2/3. And the way that you would show this with the notation is you would say, okay, when I cut up my whole into thirds, that means that I don't have 5 wholes anymore. I just have 4. And instead of just having 1/3, I now have 4/3. And when I do 4/3 minus 2/3, I'm left with 2/3. Then when I take the 4 wholes that are remaining and I subtract 3 wholes, I take away 1, 2, and 3, and I'm left with 1. And so my answer to this problem is 1 and 2/3. So that's how you can subtract mixed numbers. And again, notice that this is very similar to borrowing when you're subtracting whole numbers. And you can help your students make those connections. Now, when you have different denominators, it gets a little bit more challenging, because on top of remembering to borrow or regroup or, all of that stuff correctly, you also have to make sure that your fractions have the same denominator. So in this case, when we look at our denominators of 3 and 6, you could find a common denominator of 18 by multiplying them together, because 3 times 6 is 18. Or you could find the least common multiple by listing the multiples of 3, which would be like that, and then listing the multiples of 6. And you don't have to go very far before you realize that 6 is the least common multiple. So I'm going to go with that just because that will be easier. And I'm going to think about this as 1 and some number of 6 plus 2 and 5/6, because that second fraction already has a denominator of 6. So to make the denominator of 3 be a denominator of 6, I'm going to multiply by 2, which means that I'm splitting each of these pieces into 2 pieces, which means I now have 6 total. And the one piece that was shaded is now 2 of the smaller pieces. So now from here, I can add them together, and I'll write this out in column form. So I have 1 and 2, 6, plus 2 and 5, 6. When I add these together, 2, 6 plus 5, 6 is 7, 6, which means that I'll have a whole. And you can show that visually because if you take this piece right here and fill it in here, then you'll have one whole, and then you'll also have 1/6. So I'll write 1/6 here and a one whole over there. And then when I add my whole numbers together and I have the whole that's made from the fraction plus the 1 from the green fraction and the 2 from the so I'll take the one whole that came from my fractions, and then I'll take the two wholes that came from my blue mixed number and the one whole that came from my green mixed number. And when I add those all together, I end up with 4 wholes. And so my answer to this problem is 4 and 1/6. So it basically just adds in the extra step of finding the common denominator, and that's fine if your students are comfortable with it. However, sometimes all of the steps are difficult for them to remember. And so another way that you can do it is with the improper fraction approach. So the way that the improper fraction approach works is you change all of the fractions into improper fractions, and then you find the common denominator. And this can make it a little bit easier because then you're not having to worry about borrowing from the whole numbers or carrying to the whole numbers because you're just subtracting fractions. So the way that this would work is you would say, okay, well, if I have 2 wholes and 2/3, well, the 2 wholes are going to make 3/3 each. So they'll contribute 6/3 to the whole number. And then I have 6/3 from my 2 wholes and then 2/3 from the fraction part. And so that means that the first mixed number that I'm looking at is equivalent to 8/3. And you can see that's true because I do have 1, 2, 3, 4, 5, 6, 7, 8/3 in 2 and 2/3. And what I want to subtract is the mixed number 1 and 4/5. So I didn't draw a picture of this because I'm subtracting it, but 1 would be 5/5, and then the 4/5 is obviously 4/5. And so I'm doing 8/3 minus 9/5. Now, to be able to subtract these, I need to be able to have fractions that have the same denominator. So the least common multiple of 3 and 5 is 15, which also happens to be what 3 times 5 is. So I'm going to convert the thirds into 15ths by multiplying by 5, which basically means that I'm splitting up each of these. Whoops, I think that's too many lines. I'm going to split each of these up into 5 extra pieces. Sorry, these are really bad lines, but you guys get the idea. That we would cut these up into fifths, which gives us a total of, I think it's going to be 40, because each one of these 8/3 is now 5 little pieces. So that's going to give us 40 15ths. And then in order to subtract the 9/5, I also need to convert the 9/5 into 15ths. So 5 times 3 equals 15. And if you wanted to, you could draw the 9/5 and like show how you cut up each one of the fifths into 3 to make 15ths, which also makes the 9 pieces that were shaded into 27 smaller pieces. But for this model, I'm just going to kind of show the calculations. And we know that 9/5 equals 27/15. So now that I've got that, then I can just go ahead and subtract the ones that I need to. So I say, okay, well, I have 40 altogether. If I subtract 27 of them, so I'm going to subtract them in groups of 5 because that will make it easier. So I'll subtract these 5, then 10, 15, 20, 25, and then 26, 27. So now that I've deleted all of those, the amount that I have left is, I think it should be 13 15ths. And if you do 40 minus 27, that is true. It equals 13 15ths. And so that would be my answer. And again, you can draw this out if you want, and then just kind of draw like correlations from the stuff you're subtracting to the stuff you're subtracting it from to show that you're deleting it or getting rid of it. And I showed that in the other video about subtracting fractions. So if you want to, you can go back and review this. But this is another way you can do it as well. And probably by the time you get to this lesson, your students will be very familiar with this process of multiplying the top and the bottom and what that looks like. So you may not necessarily have to draw both of the bottles in a subtraction problem. So those are two different ways you can add and subtract mixed numbers. You can either do it by adding the fractions and then adding the whole numbers and carrying or borrowing if you need to, or you can use the improper fraction approach. So if you have any questions, let me know, and I hope you have a great day.